So the last sentence again, what did you say?
Was it 1 minus P none?
Yes.
Yeah, I don't understand that concept at all.
Oh, okay, here we go. What's the probability, right? So in 4 games, you win at least once. So we're going to use a thing that looks like this, called the complementary probability. The complementary is the probability, the opposite of whatever A is.
Yeah, and I got that one. I got that concept down.
Okay. Now, if you win at least once, in the English language, winning at least once means you win 1 game, or you win 2 of the games, or 3 of the games, or all 4 of the games, right? That's what winning at least once means. So what's the exact opposite of that?
You lose 3 out of 4.
No, you lose all 4.
Well,
right, let's say that. You win once, right? So you win once and lose 3 times, that would count, right? So you win once and you lose 3 times, that would count. How about winning twice and losing 2? How about winning 3 times and losing once? And how about winning all 4 games? Those events all belong to that you win at least once, because would you agree that in every single one of those situations, you win at least once? Some you win more than once, most of them in fact.
Yeah.
Now, what is the exact opposite of that? Well, you went and said winning 3 and winning 1. Well, nope, there it is there. Or losing 3 and winning 1. Nope, it's not that. The exact opposite of that is a very small world. You lose every game. That's the opposite event. So this is like A, and this is the complement of A. So far, so good?
Yeah, actually.
Right, now, if I want to find the probability of event A, it's really difficult because there's 4 situations. And not only is there 4 situations, even within those 4 situations, there's lots of different ways it could happen. This one here is just winning the first game and losing the other 3. But couldn't you lose the first, win the second, lose the third, and lose the fourth? You'd be here all day trying to write down all the ways of doing it. So what we're going to do instead is we're going to use this nice little property. That the probability of an event A happening is the same thing as 1 take away the probability of its composite, right? Its exact opposite. Now, in this case, that's 1 take away the probability that you lose all 4 games. But that's easy to calculate because you can only do that one way. You lose the first, you lose the second, so third, you lose the fourth. Now, if you win, what's the probability of you winning in this game? Did they tell you in the question?
0.3.
0.3. So isn't the probability that you lose going to be the rest, right? 0.7.
Yes.
Right. So this is 1 takeaway. Lose, 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 lose. This is this multiplication thing, right? Lose times lose times lose times lose. That's going to be 0.7, 0.7, 0.7. That's a long way of writing it. On my calculator, if you go 1 take away 0.7 times 0.7 times 0.7 times 0.7, and then you hit enter, you get the answer 0.7599, which is very close to being 76% of the time. So you really don't want to gamble this game because you could lose a lot of money and still it could harm, right? that you only win once about 76% of the time. And winning once won't even get you your money back, right?
Yeah.
I'm assuming in most games, you know, it's probably if you bet $1, you get $1 back, right? You win $1, right? So you don't want to take part in this gambling game because you are in trouble if you do.